Right now, something extraordinary is happening in our solar system. An object from deep space, 3I Atlas, has just reached its closest point to the Sun, and what happened next has left scientists reeling. This isn't just another comet passing through. No, this is something far more bizarre. This story started when 3I Atlas, which was first detected on July 1st, 2025, began its approach to Perihelion, the closest point in its orbit to the Sun. It was a moment that should have been uneventful. After all, we've observed countless comets in the past. They heat up near the Sun, releasing gas and dust, creating the iconic tail we all recognize. But what happened as 3I Atlas approached Perihelion wasn't just another comet getting brighter in a predictable way. This was something explosive, something scientists didn't expect, something they're still struggling to understand. When 3I Atlas reached perihelion, the comet's brightness didn't just increase at the expected rate. Instead, it exploded. That's right, it exploded in brightness. In a matter of days, the intensity of the light it emitted surged at twice the rate that astronomers had expected. This rapid brightening wasn't just an unusual occurrence, it was a shock to everyone involved in observing it. And what's even more intriguing is that scientists didn't have a clear explanation for why this happened. It's not supposed to behave this way. It wasn't supposed to get brighter so quickly, and yet here we are, watching it unfold in real time. As astronomers continued to observe the comet, something even stranger emerged. They began to notice a blue shift in the light coming from the object. What does that mean? Well, this blue shift is a signature of certain molecules, particularly carbon-based compounds like C2 and NH2. These molecules are typically found when a comet's ices are actively sublimating, when ice turns directly into gas as the object is heated by the sun. Normally, comets do show these signs, but the intensity and suddenness of the blue shift in 3I Atlas's case were unlike anything astronomers had seen before. At this point, researchers had to take a closer look. They realized that something else was going on beneath the surface. Just a few weeks before perihelion, radio observations showed that the comet was losing water at an unprecedented rate. It was releasing water at a rate of about 5.7 times 10^28 molecules per second, 40 times more than it was releasing just 1 month earlier. Think about that for a moment. 40 times more water vapor, rushing into space at a rate never seen before. Some scientists even described it like a fire hose on full blast. Now, you might be thinking that this is just a normal comet behavior. After all, comets heat up near the sun and start to release gas. That's standard physics. But 3I Atlas isn't following that standard model. The rate of increase in brightness, the timing, the way it behaves, it doesn't match any comet we've observed in our own solar system. And that's where things start to get complicated. To get a clearer picture, astronomers turn to space-based telescopes like SOHO, Stereo A, and the new GOES-19 satellite. These telescopes, equipped with coronagraphs, allow us to observe objects very close to the sun, objects that are usually hidden from our view. And what these telescopes revealed was even stranger. They saw 3I Atlas as a faint, elongated glow with no visible dust tail. Now, that's something that doesn't happen. We're used to seeing a glowing tail of dust trailing behind a comet as it moves through the solar system, but not with 3I Atlas. It was just this glowing form, without the dust. So, what could this mean? Some scientists have proposed that at first, the comet was protected by a layer of carbon dioxide gas. This protective layer might have shielded the surface of the comet from the sun's heat, preventing the water ice beneath it from sublimating. But as the comet got closer to perihelion, this CO2 layer depleted. When it did, the water ice below was suddenly exposed to direct sunlight, causing the explosive increase in brightness and activity. But here's where it gets even more fascinating. There's another possibility, one that would completely change everything we thought we knew. What if the core of 3I Atlas is made of something we've never seen before? What if its internal structure is completely different from anything we've observed in other comets? Remember, this object didn't form in our solar system. It formed around a completely different star in a different stellar environment, under different chemical conditions. Could its internal structure be unlike anything we've studied before? The James Webb Space Telescope, our most advanced space telescope, has been observing 3I Atlas, and its data has only added to the mystery. Researchers have found that the surface of the comet has been significantly altered by cosmic rays. For billions of years, this object has been traveling through the interstellar medium, bombarded by high-energy particles from deep space. And as it turns out, those particles have changed the physical and chemical makeup of 3I Atlas. The bombardment from galactic cosmic rays could have altered the surface of the object so much that it no longer resembles the pristine material from its original star system. In fact, scientists believe that the comet has developed a thick, radiation-processed crust, one that extends 50 to 65 feet into the surface. What's underneath that crust? Could there be something untouched by the radiation? Something that still represents the object's origins? That's the question many scientists are now asking. What if there's something in the core of this object that could offer us a glimpse into a completely different star system? Something that could tell us how stars and planets form in a different part of the galaxy? The truth is, we don't know yet. We're still waiting for more data, more observations, and more answers. This brings us to Professor Avi Loeb, a leading astronomer at Harvard University, who has been vocal about the need for more transparency from NASA regarding 3I Atlas. Why is he calling for the release of all the data on this object? What does he believe is hidden in that data? Is there something we're missing? Loeb's request isn't just about this one object. It's part of a larger issue, one that involves the way we study and analyze interstellar objects. If we want to truly understand these visitors from other star systems, Loeb believes we need to make all the data publicly available for independent analysis. After all, these objects are rare, perhaps once-in-a-lifetime events, and we can't afford to ignore anything. So, what happens next? Right now, as 3I Atlas moves away from the Sun, astronomers are monitoring its activity to see what comes next. Will it continue to brighten? Or will it fade as expected? The truth is, we don't know. The comet's post-perihelion evolution could be just as unusual as the outburst that occurred when it was closest to the Sun. And that uncertainty is what makes this moment so important. We're watching something unfold in real time, something that might change our understanding of comets and interstellar objects forever. But there's still more to uncover. In the next part of this story, we'll dive into the newest data from the James Webb Space Telescope, examine the theories that are emerging about the true nature of 3I Atlas, and discuss the broader implications of these interstellar visitors. Stay tuned, because the mystery of 3I Atlas is only just beginning. Part 2. The data piles up. What we've learned. So far right now, astronomers are observing 3I Atlas as it moves farther from the Sun. The comet has passed its closest approach, but the excitement is far from over. In fact, the real question is just beginning to take shape. What happens now? Will the comet continue its explosive activity, or will it settle into a more predictable, fading pattern? The strange behavior we've seen so far has already forced scientists to rethink some of the fundamental ideas they've held about interstellar objects. And now, the data is rolling in, offering new clues and raising even more questions. Let's step back for a moment and revisit the extraordinary observations we've made so far. As 3I Atlas approached perihelion, we saw this unprecedented explosion in brightness. It wasn't just that the comet grew brighter. Its brightness surged at a rate we've never seen before. This sudden outburst is a central piece of the mystery. For scientists who study comets, this is the kind of event that upends long-standing models of how these objects behave as they near the sun. Typically, a comet's brightness increases gradually as it heats up. This happens because the sun's radiation causes the icy surface of the comet to sublimate, turning the solid ice directly into gas. This gas forms a cloud, known as the coma, and it's responsible for the glowing halo we see around the comet. The gas and dust that escapes from the coma create the iconic tail that stretches behind the comet as it moves through space. But for 3I Atlas, something was different. The surge in brightness we observed wasn't a gradual increase. It wasn't just another comet getting brighter as expected. It was a sudden explosion of light, an outburst that scientists are still trying to explain. But it's not just the brightness itself that's strange. The real puzzle lies in the patterns we're seeing in the data. For example, why did 3I Atlas's light show a blue shift? As I mentioned before, this is a clue. The blue shift indicates the presence of carbon-based molecules like C2 and NH2. These molecules are associated with sublimation, but the scale of their appearance in 3I Atlas is unusual. Their presence suggests that something deeper is going on beneath the surface of the comet. Now, let's dive deeper into what makes 3I Atlas so unique. Its surface. We already know that this object has traveled for billions of years through the cold void of interstellar space, and it has been exposed to intense cosmic radiation for eons. This radiation has fundamentally altered its surface. Unlike other comets, which are typically composed of pristine ice and dust from their original star system, 3I Atlas has likely been subjected to so much cosmic ray bombardment that its surface has transformed. We now know that cosmic radiation can penetrate deep into a comet's surface. How deep? Well, according to a study led by Roma Maggiolo from the Royal Belgian Institute for Space Astronomy, cosmic rays have likely penetrated 50 to 65 feet into the surface of 3I Atlas. This radiation doesn't just change the chemical makeup of the surface, it alters the very structure of the comet's ice, transforming carbon monoxide into carbon dioxide and causing chemical bonds to break and reform. This is not just a superficial change. The comet's surface is now covered in a thick radiation-processed crust that has been fundamentally altered by billions of years of radiation exposure. But here's the critical question. What's inside? What lies beneath this radiation-altered crust? Is the core of 3I Atlas made up of material that's still untouched by the cosmic radiation? Is there still a pristine sample of material from its original star system hiding under this thick, irradiated shell? This is where the mystery truly deepens. The James Webb Space Telescope has given us a glimpse into the comet's surface composition, and what it revealed only adds to the intrigue. Webb's near-infrared spectrograph detected the carbon dioxide-rich signature of 3I Atlas's surface. But more importantly, it showed how the object has been altered by cosmic radiation. The transformation of the surface is something we haven't seen before in any other comet, and it raises a serious question. What do we do with the data? One scientist, Professor Avi Lowe from Harvard University, is pushing for transparency when it comes to the data on 3I Atlas. Why? Because Lowe believes that the data we have on this object might hold the key to understanding not just 3I Atlas, but all interstellar objects. He's called on NASA to release all scientific data gathered on the object so that independent researchers around the world can analyze it. His reasoning is clear. The data represents a rare opportunity to unlock the secrets of interstellar objects, but we can't do that if it's kept under wraps. Lowe's request to NASA is more than just a matter of transparency. It's about the future of science itself. He believes that without open access to the data, we risk missing critical pieces of the puzzle. After all, 3I Atlas is only the third confirmed interstellar object we've ever detected. The first was Oumuamua, and the second was Borisov. With so few examples to study, every piece of data is precious. If we don't share this information, we might never fully understand what these objects are, where they come from, or what they can teach us about the universe. Now let's shift gears and talk about the most important question. What happens next? As 3I Atlas moves away from perihelion and heads back out into the solar system's outskirts, will it continue to behave unpredictably? Or will its activity calm down as expected? If the behavior of the comet follows typical patterns, we should see a decrease in activity. As 3I Atlas moves farther from the Sun, it will receive less solar radiation, and its sublimation rates should decrease. The brightness should fade, and the comet's coma will likely shrink. This is what we expect from any normal comet. But this is 3I Atlas we're talking about. The comet that exploded in brightness. The comet that has defied expectations from the moment it was first observed. And scientists aren't entirely sure whether the activity will slow down or intensify. Could there be something deep inside the comet that's driving this outburst? Some researchers believe that there might be volatile material inside the nucleus of the comet that's only now being exposed to the sun's heat. As the surface layers continue to erode, this material could continue to escape, causing the comet to remain active for longer than expected. There's even a more radical possibility that has some astronomers concerned. What if the comet is behaving in ways that can't be explained by solar heating alone? What if the activity isn't just caused by the sun? Could there be an internal process, something deep inside the comet, that's driving its behavior? Some researchers are starting to ask that very question. But before we jump to conclusions, let's consider what's happening from a different perspective. The two Mars rovers, Curiosity and Perseverance, were in a unique position to observe 3I Atlas from the Martian surface. Their observations provided a different angle of view and offered scientists the chance to gather data from a vantage point that's very different from Earth's. The results from these observations haven't been fully released yet, but when they are, they could reveal new insights into the comet's behavior. One thing that we do know is that the comet came very close to the sun, and when it did, it interacted with the solar wind. The solar wind is a stream of charged particles that flows outward from the sun, and when it hits the coma of a comet, it can cause plasma instabilities, magnetic field distortions, and even particle acceleration. These interactions can tell us a lot about the structure and composition of the comet. So far, NASA's STEREO mission, designed to study the sun, has captured images of 3I Atlas interacting with the solar wind. These images show asymmetries in the gas distribution around the comet and suggest that complex dynamics are at play. As we move into the next phase of observation, it's clear that 3I Atlas is anything but ordinary. Its behavior is forcing us to rethink our assumptions about interstellar objects. Is it a comet like the ones we've studied before? Or is it something entirely different? In the coming weeks, we'll continue to gather data from observatories all around the world. The question on everyone's mind is whether the comet will settle into a predictable pattern, or whether it will continue to surprise us. What we learn from these observations could change our understanding of interstellar visitors and how they behave. Will 3I Atlas fade away into the darkness, or will it reveal even more unexpected behavior? Only time will tell. But one thing is certain: this is only the beginning of the story. Part 3. Theories emerge, the bigger picture of 3I Atlas. Now that we've seen the unexpected outburst from 3I Atlas, and we're beginning to understand its strange behavior, it's time to step back and look at the bigger picture. As the data continues to pour in, we're faced with more questions than answers. Every observation brings with it new layers of complexity, and every new theory that emerges challenges our understanding of comets, interstellar objects, and even the very nature of the universe. One of the most exciting developments to come out of the 3I Atlas observations is the possibility that this object might not just be a typical comet. What if it's not even a comet at all? Could 3I Atlas be something else entirely? Something that doesn't fit into any of our existing categories of cosmic objects? There's a growing body of research suggesting that this interstellar visitor might be far more complex than we originally thought. A closer look at the peculiarities. Let's review the key features of 3I Atlas that make it so unusual. First, there's its sudden and explosive increase in brightness. As we've already discussed, comets usually brighten gradually as they approach the sun, but 3I Atlas did so at an unprecedented rate. What could explain such a rapid change? Scientists are still considering multiple explanations. One possibility is that the comet's surface, protected by a layer of carbon dioxide, was shielded from the sun's heat for much of its journey. As it neared perihelion, that protective layer of CO2 might have been depleted, allowing the exposed water ice beneath to suddenly vaporize, resulting in a massive surge of activity. But this doesn't fully account for the comet's other behaviors. For example, the fact that 3I Atlas didn't develop a typical dust tail is another anomaly that's difficult to explain. Comets in our solar system are known for the dust tails they produce as they lose material, but 3I Atlas didn't behave this way. Instead, the comet appeared as a glowing ball of gas with no visible dust trailing behind it. The gas emissions detected were primarily water vapor and carbon dioxide. This is extremely odd. The absence of dust suggests that the comet's internal composition might be completely different from any comet we've observed in our own solar system. Could 3I Atlas be a planetary building block? Let's take this one step further. Some researchers, like Suzanne Falsner from the Forschungszentrum Jülich in Germany, have proposed a radical theory about interstellar objects like 3I Atlas. Falsner suggests that objects like this might not just be random cosmic debris, they could be the seeds of planets. According to her models, young stars surrounded by gas and dust could capture millions of interstellar objects, like 3I Atlas, which could then serve as the building blocks for planets. Think about that for a second. In a typical planetary formation model, we start with small dust particles that stick together and form larger objects. However, simulations suggest that once objects grow to a certain size, about a meter or so, the chaotic environment of a young stellar disk makes it hard for them to continue sticking together. They tend to collide and break apart, rather than grow larger. But Falsner's theory flips that idea on its head. Instead of starting with tiny particles, what if we start with large interstellar objects already hundreds of meters across? These objects could gravitationally attract more material and begin the process of planetary formation. What Falsner's theory suggests is mind-blowing. Interstellar objects, like 3I Atlas, might not just be stray comets. They might be relics of a process that helps form planets around young stars. Planets that could one day host life, just like Earth. This shifts our entire understanding of the role that objects like 3I Atlas play in the universe. Instead of being debris that's wandered the galaxy aimlessly for billions of years, they could be fundamental building blocks for planets. In other words, 3I Atlas might be a cosmic fossil, carrying with it the legacy of a planet-building process that took place around a star far, far away. The mystery of the trajectory. Let's now talk about 3I Atlas's trajectory. There's something unusual about the way it's traveling. This object is moving at a speed of over 130,000 miles per hour relative to our solar system. That's incredibly fast. In fact, it's so fast that some estimates suggest it could be around 7 to 12 billion years old, roughly 3 billion years older than our solar system. What does that mean for us? It means that 3I Atlas has been drifting through space since a time before our sun even existed. It has traveled through regions of space that we can barely imagine, encountering different stellar systems, radiation environments, and cosmic phenomena along the way. Some scientists believe that it may have passed close enough to other stars to have been influenced by their radiation, their stellar winds, and their gravitational fields. It may have even been ejected from another star system entirely, shot out into the void by the gravitational dynamics of a young planetary system. This means that 3I Atlas has a story to tell. It carries with it the traces of the many stellar systems it has encountered in its long journey. And if we can decipher those traces, we might unlock the secrets of the galaxy's past, its stars, its planetary systems, and maybe even its potential for life. The cosmic ray bombardment. Earlier, we discussed how cosmic rays have altered the surface of 3I Atlas over billions of years. But let's dive a little deeper into what this means for the object's structure. Cosmic rays are high-energy particles that come from deep space, particles that can penetrate solid matter, causing chemical reactions and physical changes. In the case of 3I Atlas, these cosmic rays have created a deep, irradiated crust on its surface. The outer layers of the comet have been transformed into something completely different from their original form. The transformation is so significant that it raises a big question. Is this outer crust all that's left of 3I Atlas's original composition? If the radiation has altered the object's surface so much, is there any of the original material left inside? Could there be something in the core of 3I Atlas that hasn't been touched by the cosmic rays, a pristine remnant of its birthplace? This is the part of the mystery that continues to elude scientists. We know that cosmic radiation has altered the surface, but what lies beneath this radiation-processed shell? Could there still be valuable information inside? Information that could help us understand the formation of stars and planets in a different part of the galaxy. The call for data transparency. As scientists continue to piece together the puzzle of 3I Atlas, one thing has become clear. We need more data. A lot more. This object is so different from anything we've observed before that every piece of information we can gather is invaluable. But here's the problem. Much of the data that's been collected on 3I Atlas has been kept under wraps. Professor Avi Lowe's call for transparency is more important now than ever. Why? Because we are only scratching the surface of what 3I Atlas can teach us. If we keep the data siloed, we risk missing out on critical insights that could change our understanding of the universe. Lowe believes that by sharing the data more openly with the global scientific community, we can uncover patterns and theories that would otherwise go unnoticed. After all, this is a rare opportunity, a once-in-a-lifetime event that could teach us more about the behavior of interstellar objects than we've learned in decades. The data isn't just about understanding 3I Atlas. It's about understanding the broader category of interstellar objects and how they interact with their environments. Every observation, every measurement could reveal something new, something that challenges our assumptions and pushes the boundaries of our knowledge. What's next for 3I Atlas? As 3I Atlas continues to move away from the Sun and head back into the darkness of interstellar space, the question is, what's next for this mysterious object? Will it continue to surprise us? Or will it settle into a predictable fade into the void? The truth is, we don't know. We're in uncharted territory. As we gather more data, we might find that the comet behaves in ways we don't expect. If the comet's behavior continues to deviate from our models, we could be forced to reconsider everything we thought we knew about how these objects behave. But if it fades as expected, we'll still learn something valuable about how comets, interstellar comets in particular, react to solar radiation. Whatever happens next, one thing is certain. The story of 3I Atlas is far from over. And as we continue to observe this extraordinary visitor, we'll keep asking the big questions. How does 3I Atlas fit into the larger context of the universe? Is it a comet, a planetary seed, or something else entirely? And what can it teach us about the origins of our own solar system? In the end, 3I Atlas is more than just an object passing through our cosmic neighborhood. It's a reminder of how much we still don't know about the universe. And every new piece of data, every unexpected observation is a step toward understanding something bigger than ourselves. Part 4. The P. Final questions. A new era of exploration. As we stand on the precipice of understanding 3I Atlas, one question remains at the forefront. What does this object mean for our broader understanding of the cosmos? The mysteries surrounding this interstellar visitor have already forced us to rethink many assumptions about comets, planetary formation, and even the nature of life itself. And now, as the comet continues its journey away from the sun and out of our solar system, we're left with even more unanswered questions than before. 3I Atlas has already shown us that interstellar objects are anything but ordinary. They are not just relics of other star systems, drifting aimlessly through space. These objects might hold the keys to understanding not only the evolution of stellar systems, but also the fundamental processes that shape the universe itself. A cosmic time capsule. One of the most fascinating aspects of 3I Atlas is its age, with estimates suggesting that it could be 7 to 12 billion years old. This object is older than our solar system by billions of years. Imagine the journey it's been on. Since before the Earth was even formed, 3I Atlas has been drifting through space, encountering stellar systems, experiencing radiation, and interacting with the environments of long-dead stars. It's a cosmic time capsule, carrying within it the traces of ancient stellar systems and perhaps even the seeds of future planets. The fact that we're able to observe this object as it passes through our solar system is nothing short of miraculous. 3I Atlas may be the only object of its kind that will ever pass so close to us in our lifetimes. It offers a rare glimpse into a time long before our own solar system came into being. But more than that, it raises an important question. How many more objects like this are out there? How many more cosmic time capsules are drifting between the stars, waiting to reveal their secrets to the universe? What we still don't know. As 3I Atlas continues its journey through the galaxy, there are still many unanswered questions about this object. What is its internal structure like? What hidden secrets does it hold? How did it form? And what can it tell us about the environments of other stellar systems? These are questions we may never be able to answer fully, but they are questions worth asking. And the search for answers is what drives science forward. Despite all the data we've gathered, there's still much we don't know. We don't know exactly how 3I Atlas formed. Was it ejected from a young star system? Was it created in the cold void between the stars? Was it part of an ancient planetary system that no longer exists? Its origins remain shrouded in mystery. But one thing is clear. 3I Atlas is a unique object, unlike anything we've ever studied before. The mystery surrounding its explosive brightening, its strange lack of a dust tail, and its unusual composition suggests that there's something fundamentally different about 3I Atlas. This object isn't just another comet from another star system. It's something more. Something that could challenge the very models we've developed to explain the behavior of comets and other interstellar objects. The search for other interstellar visitors. The story of 3I Atlas is part of a larger story, one that's just beginning to unfold. The detection of this object is a milestone in humanity's ability to observe and analyze interstellar objects. But 3I Atlas is only the third confirmed interstellar object we've ever detected. The first was Oumuamua, which sparked a whole debate about the possibility of alien technology. And the second was Borisov, a more typical comet from another star system. But 3I Atlas represents the next step in this journey. It's a comet, yes, but it's a comet that doesn't behave like any comet we've ever seen before. The big question now is, how many more of these objects are out there? With each new interstellar visitor, we learn something new about the universe. We learn about the conditions in other star systems, the types of materials that exist between the stars, and the processes that govern the formation of planets and stars. But most importantly, we learn about the history of the galaxy. Each interstellar object carries with it a story of its journey through the stars, a story that can tell us a great deal about the origins of life, the potential for life elsewhere in the universe, and the fundamental forces that shape our cosmos. But here's the challenge. Interstellar objects don't last long. They pass through our solar system quickly, and once they're gone, we may never see them again. That's why every opportunity to study one of these visitors is precious. We don't know when we'll see another object like 3I Atlas, or what we'll learn when we do. The role of transparency in science. This brings us back to the issue of transparency. As we've seen, 3I Atlas has forced us to ask difficult questions and challenge the assumptions we've made about comets and interstellar objects. But the only way we can answer these questions is through more data. That's why scientists like Professor Avi Loeb have been so vocal about the need for open access to the data. If we want to truly understand 3I Atlas, if we want to fully unlock the secrets of interstellar objects, we need to share the data with the global scientific community. The more eyes that are on this data, the more likely we are to uncover the hidden truths about these objects. The study of interstellar objects isn't just about understanding one object. It's about understanding a whole class of objects. And to do that, we need a comprehensive analysis, one that draws on the expertise of scientists from all over the world. It's about asking the right questions, testing hypotheses, and being open to new ideas, even ideas that might seem uncomfortable at first. The final frontier. Are we alone? As we wrap up the story of 3I Atlas, we are left with one final, deeply important question. What does all of this mean for our understanding of life in the universe? Could interstellar objects like 3I Atlas carry the seeds of life from other star systems? Could they be the key to understanding how life spreads across the galaxy? Or are they just the remnants of long-dead stars, drifting through space as silent witnesses to the passage of time? There's also the more existential question. Are we alone? If interstellar objects are truly the seeds of planets, could they contain the building blocks of life? If so, could life have spread across the galaxy in ways we can't even imagine? Perhaps life doesn't just begin on planets. It might begin on objects like 3I Atlas, which then carry the potential for life to new and distant worlds. These are the big questions. Questions that go beyond the scope of 3I Atlas itself, but questions that this object might help us answer. The discovery of interstellar visitors challenges our assumptions about the nature of life and the universe. They force us to reconsider what's possible and what's out there, just waiting to be discovered. The legacy of 3I Atlas. In the end, the story of 3I Atlas is one of discovery. It's a story that's still unfolding, one where every new observation could lead to a breakthrough in our understanding of the cosmos. But more than that, it's a story about how the universe constantly surprises us. Just when we think we have it all figured out, something like 3I Atlas comes along and forces us to reconsider everything we thought we knew. As we continue to study this object, we'll likely learn more about the forces that govern the universe. We'll learn about the ways in which stars, planets, and life itself form. And we'll learn about the mysterious, unpredictable nature of the universe. 3I Atlas has already taught us a great deal. It has challenged our models, disrupted our expectations, and opened up new avenues of research. And in the years to come, the legacy of 3I Atlas will continue to inspire scientists, researchers, and curious minds everywhere to ask the big questions, to keep pushing the boundaries of what we know and exploring the great unknown. As we say goodbye to 3I Atlas, we'll look to the future, because the universe is vast, and who knows what other mysteries await us just beyond the horizon. The journey of discovery is far from over, and this is just one chapter in the ongoing story of the cosmos. Part 5, The Unexplained Behavior, Decoding the Anomalies. At this point, we've observed 3I Atlas long enough to know one thing. It's far from ordinary. This interstellar object has upended nearly everything we thought we knew about comets. Its explosive increase in brightness, lack of a dust tail, and strange composition are just the start. The most pressing question now is, what exactly is driving these anomalies? Why is 3I Atlas behaving so differently from anything we've observed before? Is it simply a comet on an unusual trajectory, or is there something deeper at play? Let's break down some of the key anomalies in more detail and explore potential explanations. The surge in brightness. Is it solar heating or something else? One of the most striking features of 3I Atlas's approach to the Sun was its unprecedented surge in brightness. When comets get close to the Sun, they naturally heat up, causing ice to sublimate and releasing gas and dust. This process makes the comet brighter as it emits more light. This is what we expected when we first started monitoring 3I Atlas. But then, something strange happened. The comet didn't just gradually get brighter. Its brightness surged at an unprecedented rate, increasing at twice the expected rate. At first glance, this could be explained by the comet's proximity to the Sun. After all, the closer a comet gets, the more it's subjected to solar radiation, and the more active it becomes. But this wasn't just a normal increase in activity. It was an explosive outburst. So, why? Could it be that 3I Atlas has a different composition compared to comets in our own solar system, one that reacts much more intensely to solar radiation? The possibility that 3I Atlas is composed of ice that sublimates far more readily than expected could be part of the answer. But there is also the possibility that something internal to the object is contributing to this activity. Could 3I Atlas contain volatile materials that, when exposed to solar radiation, trigger a more intense reaction? This would suggest that the behavior we're seeing isn't solely due to the Sun's heat, but rather something within the comet itself. Perhaps even an internal mechanism triggered by proximity to a star. The lack of a dust tail, a puzzle to solve. As we've mentioned before, 3I Atlas does not have the typical dust tail we expect to see in comets. The lack of a dust tail is so unusual that it's led to a flurry of hypotheses trying to explain it. Some scientists have suggested that 3I Atlas might be composed of mostly gas, with little solid material to form the dust particles that typically create the visible tail. This theory fits with the high amounts of carbon dioxide detected in the object's emissions. As the object heats up, it could be shedding more gas than dust. However, even this explanation doesn't fully solve the puzzle. Comets are known to produce gas and dust as they approach the Sun. This is what makes their tails so visible and spectacular. So, why would 3I Atlas not follow this pattern? Some researchers have speculated that the object might have been shielded from the Sun's radiation until very recently, possibly by a protective layer of CO2 gas, which may have only been depleted as it neared perihelion. But even this theory doesn't fully account for the comet's sudden explosion of brightness. So, the mystery remains. Is 3I Atlas simply an outlier, a comet that doesn't behave like other comets? Or is there something fundamentally different about this object? The fact that we're still struggling to come up with a solid explanation suggests that we might be dealing with an object unlike anything we've ever encountered. Could there be an internal engine? As odd as it might sound, some researchers are considering the possibility that 3I Atlas could be more than just a natural object. It could have an internal structure that's capable of triggering its own outbursts. Now, this idea might sound like science fiction at first, but let's pause and think about it for a moment. We've already observed that the comet behaves in a way that doesn't seem to match our models. The explosion of brightness, the lack of a dust tail, and the apparent lack of solar heating in some parts of its behavior. All of this points to something strange happening inside the object. What if the object is engineered in some way, perhaps to release gas or energy at certain intervals, triggered by specific conditions, such as proximity to a star? Of course, this idea is highly speculative, and there's no direct evidence to suggest that 3I Atlas is anything but a natural object. However, the fact that it behaves in such a highly irregular way is a clue that we cannot ignore. It's possible that we simply don't have the right framework to understand the object's behavior yet, and we need to expand our models to account for this kind of anomaly. Part 6. Cosmic Implications. What 3I Atlas teaches us about the universe. As we continue to track 3I Atlas and its strange journey through our solar system, the implications of its behavior reach far beyond just understanding comets or interstellar objects. The questions that 3I Atlas raises are fundamental to our understanding of the cosmos. Its behavior challenges not just our models of comets, but our models of the universe itself. A window into other star systems. 3I Atlas isn't just a comet. It's a window into the nature of other star systems. Unlike objects formed in our solar system, 3I Atlas is a product of a completely different environment. Its internal structure has likely been altered by exposure to cosmic radiation, and its composition is vastly different from the comets we are familiar with. By studying 3I Atlas, we gain insight into the conditions of a distant star system, conditions that we may never be able to observe directly. This idea of studying interstellar objects to learn about other star systems has major implications for our understanding of planetary formation. If 3I Atlas's composition is radically different from the comets in our own solar system, it could suggest that the process of planet formation in other star systems works differently than we thought. Perhaps the chemical makeup of comets varies significantly depending on the type of star around which they form, the age of that star, or the materials available in that stellar environment. Understanding the processes that shaped 3I Atlas could help us develop new models of how planets and stars form in other parts of the galaxy. If this object is a remnant of a star system that existed long before our sun was born, it could offer a glimpse into the early days of the galaxy itself. The possibility of life beyond our solar system. One of the most profound questions raised by 3I Atlas's journey is the possibility of life beyond our solar system. As we know, comets are thought to be carriers of organic molecules, those key building blocks of life. Could objects like 3I Atlas hold the potential for life? While this is a speculative idea, it's one worth considering. If 3I Atlas formed in a distant star system, and if that system had conditions conducive to life, could the building blocks of life have traveled with it across the galaxy? Could 3I Atlas carry not just the chemical remnants of its home system, but also the potential for life itself? It's a tantalizing idea, one that opens up a whole new realm of possibilities for the spread of life in the galaxy. The fact that we're studying an object from another star system provides us with a unique opportunity to examine how life might travel between the stars, whether via comets, asteroids, or some other method. Could life be more widespread than we realize, spread across the galaxy through objects like 3I Atlas? This is something we're still exploring, but it's one of the most exciting possibilities raised by the study of interstellar objects. The future of interstellar exploration, 3I Atlas, is just the beginning. The detection of this object is a milestone in our ability to study interstellar visitors, and it marks the beginning of a new era in space exploration. As technology improves, we'll be able to detect and study more objects like 3I Atlas, and each one will bring new insights into the nature of the universe. But this also raises an important question. How can we better prepare for the study of future interstellar objects? The tools we have today, such as the James Webb Space Telescope, are revolutionizing our ability to observe distant objects. But what if we could send probes to study these objects up close? What if we could capture samples from an interstellar comet or asteroid and bring them back to Earth for analysis? These are questions that are likely to be explored in the coming decades as we continue to push the boundaries of space exploration. The future of interstellar exploration is bright, and 3i Atlas has opened the door to a new era of discovery. The potential for learning about other star systems, other planetary systems, and the origins of life in the galaxy is vast, and we are just scratching the surface. The legacy of 3i Atlas. As we watch 3i Atlas continue its journey out of our solar system, we can't help but feel a sense of awe at what we've learned so far. This object has already forced us to challenge our assumptions, rethink our models, and ask questions that we never thought we'd ask. And while the comet will soon be gone, the knowledge it has given us will stay with us forever. 3i Atlas has shown us that the universe is far more complex and mysterious than we could have ever imagined. It has revealed new truths about the galaxy, about the building blocks of life, and about the strange and unpredictable behavior of objects from other star systems. As we continue to study this remarkable object, we'll undoubtedly uncover more secrets that will change the way we view the cosmos. In the end, 3i Atlas has taught us one thing: the universe is vast, mysterious, and full of surprises. And with each new discovery, we move one step closer to understanding the true nature of the cosmos and our place in it.